Sorry, it's DJ.
Hello, Mahtang Lawins. This is Teacher Sider, your tour guide in the world of numbers. Today, let's relate our lesson into real-life situation. But before that, let's warm up our mind in this simple riddle. I will give you 15 seconds to answer. The timer starts now. Time's up. Now, let's reveal the answer. Did you get the same answer? Very good! Now, let's proceed to the application of rational expressions. Let us solve problems using proportions. But first, we are going to define what is ratio. Ratio enables us to compare numerical quantities. For example, a certain chainsaw requires that the gasoline be mixed with oil in the ratio of 32:1. In the stock market, winning stocks might outnumber losing stocks in the ratio of 7:3. The ratio of A to B may be written in any of the following ways: A to B, or A is to B, or A over B. On the other hand, a proportion is a statement that two ratios are equal. For example, 1/2 is equal to 4/8, or 3 supervisors over 25 workers is equal to 12 supervisors over 100 workers, or A over B is equal to C over D. Proportions are a useful and important type of rational equation. A toy model indicates on the box that 1 inch on the model is equivalent to 18 inches on the actual automobile. How long will the model be if the actual automobile is 15.75 feet long? Let X represent the length of the model car. If the actual automobile is 15.75 feet long, then it is 189 inches long. The ratio of 1 to 18 should equal the ratio of X to 189. So, our equation will be 1 over 18 is equal to X over 189. The LCD of these two fractions, 1 over 8 and X over 189, is 3,402. So, we are going to multiply both sides by the LCD 3,402, and we will get 189 is equal to 18X. Now we are going to solve for X, and we will get 10.5 is equal to X. So, if the actual automobile is 15.75 feet long, or 189 inches, the length of the model will be 10.5 inches. Here is another proportion problem involving rates. Alicia spent 5 hours studying for her last accounting exam and got 60% of the exam. She has already studied 2 hours for her upcoming second exam and would like to get 90% of that exam. If we assume that Alicia continues to increase her score at the same rate as before, how much more should she study to get 90%? Let x equal the additional number of hours of study needed to get 90% on the next exam. So, the equation will be 5 over 60 is equal to 2 plus x over 90, where 5 is the hours of study and 60 is the percent on exam, and 2 plus x is hours of study and 90 is percent on exam. The LCD of these two fractions is 5,400. Let's multiply both sides by the LCD 5,400 and we will get 450 is equal to 120 plus 60x. Let's transpose 120 on the other side. 450 minus 120 is equal to 60x. Subtract 450 to 120 and we will get 330 is equal to 60x. Now, let us solve for x. We are going to divide 60 on both sides. Therefore, x is equal to 5.5. So, in order for Alicia to get 90% on her next exam, she needs to study an additional 5.5 hours. Here is another problem involving distance, rate, and time. The current of a river is 3 miles per hour. It takes a motorboat a total of 3 hours to travel 12 miles upstream and return 12 miles downstream. What is the speed of the boat in still water? To solve this problem, let x represent the speed of the boat in still water. Since x is the speed of the boat in still water, the rate upstream is x minus 3, and the rate downstream is x plus 3. The time can be determined using the formula T is equal to D over R, or time is equal to distance over rate. It can be summarized using the table. So, our equation will be 12 over x minus 3 plus 12 over x plus 3 is equal to 3. Now, let us solve the rational equation. Multiplying both sides by the LCD of the quantity of x minus 3 times the quantity of x plus 3, and we will get 12 times the quantity of x plus 3 plus 12 times the quantity of x minus 3 is equal to 3 times the quantity of x squared minus 9. By applying distributive property, we will get 12x plus 36 plus 12x minus 36 is equal to 3x squared minus 27. By combining like terms, we will get 3x squared minus 24x minus 27 is equal to 0. Divide each term by 3 and we will get x squared minus 8x minus 9 is equal to 0. Now, let us going to factor x squared minus 8x minus 9 is equal to 0. And the factors are x minus 9 and x plus 1. So, the value of x is 9 or negative 1. And we can now conclude that the speed of the motorboat in still water is 9 miles per hour. Note, we do not use x is equal to negative 1 because the speed of the motorboat cannot be a negative number. Work problems are closely related to time, rate, and distance problem. People work at different rates. If the letters R, T, and A represents the rate at which the work is done, the time required, and the amount of work accomplished respectively, then A is equal to R times T. Notice the similarity to the distance formula. D is equal to R times T. Amount of work can be measured in terms of jobs accomplished. Thus, if one job is completed, A is equal to 1. And the formula gives the rate as 1 is equal to R times T, or rate is equal to 1 over T. Here is an example of work rates problem. An inlet pipe can fill a backyard pool in 10 hours, while the drain can empty it in 12 hours. If both the inlet pipe and the drain are open, how long will it take to fill the pool? Let X represent the time it takes to fill the pool with both the inlet pipe and drain open. Since the inlet fills the pool in 10 hours, it completes 1/10 of the job per unit time. Since the drain empties the pool in 12 hours, it completes -1/12 of the job per unit time. Take note, draining is the opposite of filling, so the rate is negative. This information can be summarized in a table. Since together both pipes affects the completion of one job, the sum of the fractional parts accomplished by them should equal to 1. So, our equation is 1/10x plus -1/12x is equal to 1. Or 1/10x minus 1/12x is equal to 1. The LCD of the fractions is 60, so we are going to multiply 60 on both sides. And we will get 6x minus 5x is equal to 60, or x is equal to 60. Therefore, it takes 60 hours to fill the pool if both the inlet and drain pipes are both left open. Watch again the videos if you want to check your answer. From the lesson we've learned, did you realize how important studying algebraic expression is? For more digital video lessons, subscribe to our YouTube channel, Vivan's Math Warriors, and don't forget to hit the notification bell. Thank you for watching.